Hello everybody and welcome to our video today. We will be talking about Physics Chapter 9, Nuclear Phenomena. Okay, so let's get started. There's a few important details to cover in this chapter, first of which is the photoelectric effect. And the photoelectric effect is the ejection of an electron when light is absorbed. So when light is absorbed, light is converted into energy. So there's a couple of equations that kind of go into this. So first we have the energy of a photon, right, equals hb. We've seen this equation in a previous video. Then we have this symbol right here, which means the work function. And the work function is the minimum energy required to emit a photon from a metal surface. And then we have this equation, which is saying that the energy of the photon equals the kinetic energy of the electron plus the work function. So if we're putting these things together, we're going to say that the kinetic energy of the electron equals to hv minus work. So we're using the energy of the photon, the work function, and the kinetic energy of the electron, okay? So that is what we are putting in here. Just one formula to know. So next we will talk about fission and fusion. So fission is when a larger nucleus splits into smaller nuclei. Fusion is the combination of smaller nuclei into a larger nuclei, okay? Next we have exponential decay, and we have this formula here. It's n equals n naught e to the exponent negative lambda t. So basically this equation is proportional to the material present, okay? And you'll see if you look at the graph, it's, exponential decay. You'll recognize the exponential graph. And n is the number of undecayed nuclei. N naught equals the number of undecayed nuclei at t equals 0. And then we have lambda, which is the known decay constant, okay? So next, let's turn over on this side and let's look at electron capture first. So electron capture is the process that an unstable atom uses to become stable. So it's when an electron from one of the shells is actually brought into the nucleus and combines with a proton to form a neutron. Okay, so think of it, the nucleus is capturing an electron in one of the shells and bringing it inside to form a neutron, okay? So then finally in this chapter, the important thing to note is the radioactive decay types, okay? So we have alpha decay, which is when a helium is emitted. So you'll have your element right here, right? And this is the atomic number, this is the atomic mass, and this is the element. This is the formula for alpha decay. So you'll notice that it will change the mass by 4, the atomic number by 2, and it will also emit a alpha particle, which is emitting a helium, okay? Next we have beta positive decay, which is taking a proton and turning it into a neutron. So this is when, again, you'll have your element, you'll see a change in the atomic number, and then you will also see a beta particle, a positive beta particle emitted. Beta negative decay is when you're taking a neutron and it's converting into a proton, and so then you have your element, you'll see the atomic number +1, and there is also emission of a negative beta particle, okay? And then finally we have gamma decay, which emits photons but does not change the element. So this is, simplified, but it does not change the element. So that's one thing you can definitely remember about gamma decay. And with these ones, you'll just have to look at whatever the starting element is and how it changes here. So does this number go up by 1, down by 1, down by 2, or what other particles are emitted here? So those are the types of radioactive decay. So I would definitely look at some examples and just kind of go through and make sure that you can recognize and that you know what is happening in each types of decay. So please put your comments below and we'll see you in the next video.